In this last bit of chapter 5, I'm going to do a couple little examples involving Java and Python classes, and I'm going to make some more comparisons between the languages. Now, we're going to make a Java class called MyMethods. Now, you'll notice the word public here, and we've talked about that before. That means visible outside of the file. Then we have this public here. We're going to say public double square. So we're making a method. And you can see some things that you don't see in Python. One thing you can see right away is this. That right here, we're specify the return type. So when you make a function, you specify the return type. So what's interesting, you've seen the main method, and it says void. A void return type means that a function does not return anything. And you'll also notice this. At compile time, we have to know the types of all arguments of methods. So let's go ahead and do this. Now the return statement that you see here works in a manner entirely similar to that in Python. It does two things. One, it terminates the execution of the method. Two, it returns the output of that method to whomever happened to call it. Okay, so let's go ahead and compile this program. We're going to go ahead and do that. It does not have a main method, so we cannot run it. But I went ahead and compiled it. And now what I'll do is I'll just get good old JShell out. Okay. And as soon as JShell opens, I can now make an instance of my class. How do I make an instance? I use the new keyword. Okay, so I can say m.square of 5. And it does exactly what I expect it to. It returns a double that is a square. Now, let's do exactly the same MyMethods class in Python. So let's go ahead and quit or exit. And here it is in Python. Okay, and I'm going to put my object thing in here because I want to be fully Python 3 compliant. All right. I have to get the self argument in Python, and I'm going to say return x times x. All right. There it is. Okay. And now let's go ahead and run this and see that it runs. Okay, so the compiler or the interpreter found it as acceptable. Okay, so I went ahead and imported it. Now, well, here's something that's different. Variables don't have type, so I don't specify the variable type. There is no new keyword in Python. But otherwise, there we go. I've just made an example. And I say m.square of 5. And boom. What's interesting here, by the way, what you should note, Java gave me a double. Because Java knows all types at compile time. Python, on the other hand, is different. Python Python can be described as a dynamically typed language. In other words, decisions about type are made at runtime. Whereas Java is a statically typed language. Decisions about type are made at compile time. Now you'll hear some people mistakenly say Python is a weakly typed language. They are dead wrong. Because we all know from having used Python that Python objects are acutely aware of what type they are. What's untyped are variables. Variables are simply names with no type. In Java, variables are names, but they may only point at a variable of the same or at a datum of the same type that they are. In general, I'll say this, Control D, so let me go ahead and bail out of here. Okay. Oh, let me get rid of this. So, in general, Java methods all look like this. They look like this. Public or private, depending on whether you want the method visible outside of the class. Then what you say is the return type, whatever that happens to be, and double float string. Then you say function name. Then what you have to do is specify types for all of your arguments. All right. And then you put open curly brace, close curly brace, and inside you must return an object of the correct type. You must return data of the correct type. Okay, whereas in a Python function, you simply say def function name arg1, arg2, and nothing is said about the types of the arguments, colon, and then you have the code for your function. Now, one thing that Java has that Python doesn't is something called the signature. The signature of a method is just the list of types in its argument list. And so, in this case, it would be type 1, type 2, okay, etc. So the signature of a method is the list of types. If there are no arguments in the function, you say the function has an empty signature, or you'll commonly hear me call it a sig. Okay, so the sig of a function is just a list of types. You'll notice that the names, the nicknames we give the arguments do not matter. They are not a part of the signature. The only thing that's a part of the signature is the types. Now, here's something that you'll find interesting. Let's go back into JShell. Let's reopen our friend here. And let's make an instance of him. That up arrow key comes in handy. Now let's stick a character in here. Ooh. So notice a strange thing is happening here. Oh, my methods is accepting a character. Whoa. And squaring it. So you do have an undesired result there. And the reason that this is happening is because Java is happily saying, oh, A. A is an integer. A can be thought of as an integer, so I'm going to make it an integer. Then I'm going to, then it's going to say, oh, but this accepts a double, but an integer upcasts to a double happily. So we go from A to 97, an integer, to 97.0. And when we square 97.0, we get this. That's kind of an ugly surprise that can happen. Okay. Let's go back out here. We're going to add something to both of our classes. Okay. MyMethods.java. Public string. So we'll make a string here. Okay, so string can be a return type. It's a type. And we'll talk a lot more about strings very soon. And we'll say Dublin of string X. All right. Oh. Oh yeah, let's do this just for fun. All right. So here's my Java. I'm going to bail out of here. I'm going to open my Python file and I'm going to do the same thing. And I'm going to say, let's call this X. I don't care. I'm going to say return times 2. All right. So there's my methods class. Now let's do a little spelunking here. First I'm going to run that. All right. And then I'm going to say from my methods port my methods. Now I'm going to say m is equal to my methods. I'm going to make an instance. I'm going to say m.Dublin of 5. Oops. I'm going to go back in here and get rid of that O that I accidentally put in there. Hey, look, 10. Ooh. So this is interesting about Python. Python is what you would call a duck-typed language. If it walks like a duck, if it quacks like a duck, it's a duck. So what's happening here, all right, let's quit. Let's go back into our code, is X that is being passed in, which was cow's space, can be multiplied by 2. So that decision is made at the time the program is run. You can multiply a string by an integer, and the result is the string is repeated twice. Now we did the same thing in Java. Let's see what happens there. Uh-oh. That's very bad. So, we can fix that, however, because in Java, strings do this. All right. Let's try this on for size. Oops. Did I not get rid of that? I did get rid of that. Oh, I did that in the Python file. My bad. Let me put that back. That would be bad. I want to do this in the Java file. That was kind of Kafka-esque. It was a bad mistake. Okay, that'll do the job. Ooh, compiles. We open it with JShell. Now in JShell, watch what happens. We're going to go my methods M, because M is a variable of type my methods. When I make a class, I'm making a new type. Okay, new my methods. So the Java virtual machine just spit me out. Oh, I need to open it first. Let me find that. Oh, there it is. And then, beautiful. The Java virtual machine just made me an object of my methods type. And so if I go m.dublin of cows, beautiful. Now I'm going to put 5 in there. Python happily slurped that up and spat out a 10. But Java did not. Java is much stricter about type. Types must be known at compile time. Now you saw an exotic little example of where I did something that I really was not supposed to and got away with it because of the fluidity between integers and characters. However, this is more typical. If you pass in an object of the wrong type, just about all the time you're going to get a compile time error. Now this sounds bad because Java is more restrictive, but it's also good because the compiler can save you from making errors that are hard to ferret out. So this rounds out our introduction to Java. So far, what have we seen? We've seen all code in Java must be inside of classes. That a class needs to have a main method in order to be executable. But a class can have other methods. And we're only at the beginning of that. And we learned about the 8 primitive types. 4 integers: byte, short, int, which is the most common integer type, and long. 2 floating point types, which are IEEE 754 floating point numbers, and they are float, which is a 32-bit floating point number, and double, which is a 64-bit floating point number. Incidentally, double is the preferred floating point type, and it's the one we will use throughout. Then we learned about Boolean, which has only 2 values, true and false. And we learned that Boolean's casting is a lot less fluid than Python's. This notion of truthiness is much more restricted in Java than it is in Python. And finally, we learned about the character type, which has some fluidity with the integers. Characters are stored as bit patterns and the bit pattern is simply the base 2 expansion of its ASCII value. So next time, what we're going to do in the next chapter, we're going to start talking about the other type in Java, the object types, and how those work. And we will also learn about reading the documentation and figuring out how to make Java objects do work for us. So I will see you next time.